So in this video, we're going to talk about finding the domain from equations. So we're dealing with Roman numeral 2. And the first thing we're going to do is talk about the domain of a function. So let's talk about this finding the domain of x squared minus 1. So the idea behind a domain is to try to find a restriction. So let's think about a way that we could figure out if we're going to get a real number or not. And so is there a possible way to take a number, square it, and then subtract 1 and get a not real number? And so the answer would be no. So if there's no way that this is going to give you an undefined or an imaginary number, then there is no exclusion. And if you kind of think about the graph of this, that's another way to do it, is to think about that graph. We can look at that graph and know that, oh, okay, yeah, the domain would be from negative infinity to positive infinity. So the domain in this case is going to be all real numbers, and then in interval notation, it's negative infinity to infinity. All right, so you're always trying to find a restriction. So let's take a look at part B, where we're specifically talking about a denominator. So remember, with fractions, you are not allowed to divide by 0. So if you have a number and you divide by 0, it is going to give you something that is undefined, right? And we've talked about that before. Just a little reminder that it is okay if 0 is on top, that equals 0, but it's no if 0 is on the bottom, right? So just that little hint right there. Remember that you cannot divide by 0. So the intent was, when you have a denominator, is to set the denominator not equal to 0 to find the restriction, okay? Or actually, you wouldn't be finding the restriction. The restriction would be equal to 0, but you set the denominator not equal to 0 to find the domain. So what we would do is just go 2 minus x. We know that that value cannot equal 0. If it does, then we have an undefined situation going on. So obviously we just would subtract 2. We get negative x cannot equal negative 2. Therefore, x cannot equal 2. So x or 2 would be my restriction, but my domain is going to be everything, right? So we could do a number line. Everything except 2. So that would be from negative infinity to 2. And then we join on the other side of 2 and go to infinity. All right. So just remember that you cannot divide by 0. So now let's take a look at a function that involves an even root. So think about that in terms of, if you had a square root of a negative number, that is going to be an imaginary, which means that it is not real. The cubed root of a negative number is still okay, right? So if I had the cubed root of negative 8, that's going to give me negative 2. But if I had the square root of negative 8, well, that's going to be an imaginary number. Same thing with the fourth root of negative 8. That's also going to be an imaginary number. So even roots will produce imaginary numbers. So therefore, we need to make sure that with even roots, we have something that we ensure we are going to get positives. So when we have the square root or an even root, we take the radicand and we say that the radicand has to be positive. So we take the radicand and we set it greater than or equal to 0 to ensure that we have positive numbers and 0. Okay, so it's okay to take the square root of 0, right? Because the square root of 0 is 0. So in this case, we have 7 minus x is greater than or equal to 0. So we are just going to go ahead and solve. We have negative x is greater than or equal to negative 7. I am dividing by negative 1. So I have x is less than, remember that when you divide by a negative, you have to flip that inequality. So x is less than or equal to 7. So on a number line, that is going to be solid, and then it is going to the left. So in interval notation, we would have negative infinity all the way to -7, and it includes -7. All right. So if you have any questions, make sure to address them.